how do we generate? So that is what the question in the previous class I asked you to do it as an assignment. How many of you are able to do it? Did anyone else try to solve it? Please respond. So you can see that, so first pulse, this is the first pulse. If I am considering this as an first pulse to be considered for the very first beginning of the programming, first pulse period is T is 100 milliseconds, but T on in this T on and off, it is equal to 50 milliseconds. Only the value that you are supposed to send to the port, which port it has been asked at which you need to generate, it is at port 1.2, and since we go for the timer to program this one, yes? Students, someone was talking something. No? Okay. So the T on period and T off period for the first pulse, it is equal to 50 milliseconds. Later, 5 times. So here 5 times on and off period. So 1, 2, 3, 4, 5. So 5 times on and off, T on and T off, that you are supposed to generate for 20 milliseconds. So this is the type of problem which has been given. Here only 4 pulses are there. Please students, you can add it one more pulse so that you can see that there are 5 pulses. Okay, 5 pulses. Now the program you have to write for the timer, as it is to be written for timer. Which timer we have to choose? Let us first define. Let me consider as timer 1 in mode 1. So this is the consideration I'll be doing for an program to write. So similarly, if in the question paper, if it is not clear for you which timer to be used and in which mode to be used, better always you go for timer 0 or timer 1 in mode 1. Okay. Now let us move forward. How to generate for such a pulses the program, the actual time delay. So if you go for time delay, first you need to generate the time delay for 50 milliseconds. Required time delay either for on period or off period, T on or T off. Okay, T on or T off, it is for 50 milliseconds. So therefore, let us solve first delay computation for 50 milliseconds. How much the initial count value that is supposed to be loaded onto the timer TH as well as TL registers. If you are calculating this TD, 50 milliseconds is the required time delay. 50 milliseconds, that is equal to the final value, since it is of timer 1 in mode 1, FFFH minus the initial value is to be found, initial value. So let me write that initial value as it is, and then multiply this with 12t. So if the computation of initial value it has been done, please calculate as you have done in the previous class. So initial value, it is found to be B875H. So that is the initial value to be loaded on the TH1 and TL1. So when you go for this TH1 and TL1, TH1 you have to load with B8, that is 0, B8H, and TL1 you need to load with 75H. After loading, TMOD register you have to find out. So TMOD register timer 1 in mode 1. So therefore the timer value when you are computing, so these 4 bits are don't care because timer 0 we are not using, whereas timer 1 in mode 1 this will be 0 1, whereas this is 0 0. So it gives an value of 10H. So after computing the timer with TMOD value of 10H, how many times this 50 milliseconds needs to be repeated? So 50 milliseconds needs to be repeated for on period and off period. So only twice. So therefore what I'll be doing, I'll be going for the looping looping technique to complete this particular program. Similarly, when the 20 milliseconds, if it is considered, this 20 milliseconds, actually it is for the 5 pulses. So therefore 20 milliseconds delay needs to be repeated for 5 times. So similarly, you find out when TD is given as 20 milliseconds, what is the initial value that is supposed to be computed. So initial value, if you are computing, please make these computations or calculations are from your end. Just I'll be writing what are the values supposed to be found placed on TH and TL register. So how much will be for 20 milliseconds? Could you please calculate how much we are supposed to have for this 20 milliseconds? Can anyone able to calculate? Are you going to calculate or shall I calculate?
Calculating.
Yeah, calculate and tell me. Can I write the formula? Yeah,
Yes,
initial value it is F minus required time delay is 20 milliseconds divided by 12 into 1 by 22 megahertz. So please calculate and tell me what is its equivalent. This you can convert into, this is in terms of hexadecimal. Please convert into the decimal value and thereby subtract this value. 65,535 I think, minus this value you will be getting some initial value.
70C4, ma'am.
1 minute, ma. Yeah. Now it is 11 0
7, ma'am. 70C4 I'm getting, ma'am.
70C4H. Okay. Now this is for 20 milliseconds and this B875 for 50 milliseconds. So we have done all the computation parts. So now let us go for writing the program. So what I'll be doing is initial when we look at the waveform, the initial value to be sent to the port 1.2 pin as high value. So therefore only a single pin need not to be having is multiple bit values like what previous problem we have done it. So you can say that particular pin itself to an high or low value. So set B. So what I'll be doing? Program org00h. So now since the initial value is supposed to be I, set B P1.6. So this P1 dot, which pin it is supposed to be? P1.2. Yeah, sorry. P1.2. Okay, P1.2 I have set. So high value you can see here. After a high value at port 1.2. So now this has to be initially it at time t is equal to 0. P1.2 has sent with an I value, but that has to be retained for how much duration? It has to be retained for 50 milliseconds. So therefore you need to provide that delay through the timer 1. Already the initial value we have computed to be loaded on TH1 and TL1. So load it. But this particular 50 milliseconds has to be repeated for twice. One for the on period and the other one for the off period. So what I have to do? So first let me set the bit at port 1.2. Then initialize the tmod register. Tmod with what value? It is with hash 100h. This tells that we have chosen timer 1 in mode 0. Mode 1. That is a 16-bit timer. And how many times this R1 value, this 50 milliseconds has to be repeated in the waveform? So that is twice. So therefore let me define one register with this how many times of this 50 milliseconds needs to be repeated. So that will act as a counter. Next, move TH1 with what value? Because initially 50 milliseconds. To provide this 50 milliseconds, the count value what we got is 50 B875. So therefore what I am doing, TH1 with 0, B8H and move TL1 with hash 75H. Okay. So now I have initialized the count value to an 50 milliseconds initial value, and that has to be retained for 50 milliseconds. So therefore start the timer. So set B TR1. So start the timer and then keep monitoring the overflow flag. When the overflow flag you are monitoring J and B, which flag related to timer 1? It is TF1, comma again. So again should go to the same instruction. So therefore we are going for again to the same instruction. Once this particular delay or count reaches to 0, it means to say that 50 milliseconds of delay has been provided through this timer. So clear TR1, then clear TF1. Again this has to be repeated for off time also. But for an off time, what is the value that you are supposed to send it to? The port 1.2, it is
0.
Yeah, 0. So therefore what is we have to do? It is CPL complement P1.2. After complementing, okay, complementing DJNZ R1 comma back. Where that back has to go? Back has to go to initialization of our set B. No, it is only sending the data. So I'll tell you when I have to go for set B P1.2 to that instruction. Okay, is it clear now what is happening? twice this will get repeated, but what is the waveform that you will be observing on port 1.2 for 50 milliseconds on time and for 15 milliseconds off time. Once off time comes, already this particular CPL P1.2 1 has become 0. So therefore you need not to go for again this complementing. Instead of that, what you can do, again, if you want, you can set back, because off period after it gets over, you can set your 1 minute, set your port 2 bit, port 1 bit to high value. Otherwise, you can continue. But better when you are learning the program for the timers initially, you can set the value to initial value. So set B P1.2. Again I have done because 20 milliseconds on period I need to generate. But for this high value, what should be the delay that I am supposed to give? Set B means this value I am getting. It should be provided for 20 milliseconds. So therefore, what is the count? How many number of pulses it is supposed to be generated? It is supposed to be generated for 5 times. So what I'll be doing? I'll be initializing the counter. Let me define R2 with #05. You understood why this R2 with 05 I am initializing? Okay. Now, it is not the same delay we are providing. We are providing 20 milliseconds. For 20 milliseconds, the initial count value that we got is 70C4H. So that value you need to move on to TH1 and TL1. So hence move TH1 with 70H. So #70H, and then move TL1 with #C0C4H. Next, what should be done in the program? What is the next instruction? Set the timer 1, then what is that? We need to keep on monitoring the overflow flag. So therefore, what you will be doing? The JNB TF1 comma back 1. So these labels when you are using, please remember same labels you cannot make use for multiple loopings. You keep changing the label names. Back 1, that back 1, let me write to the same instruction. This has to be repeated for how many times? 5 times. So therefore, once it comes out from the looping, so you need to clear the timer and you need to clear the overflow flag, and you have to complement the P1.2. And again, since we need to repeat this process for 5 times, DJ NZ R5 comma, where it has to be loop 1, where that loop 1 has to be, to which instruction can you tell me? So this loop 1 should go where?
So set BTR.
Set? No. Why you tell me? Because the initial value to be loaded, the 20 milliseconds initial value, it has to be loaded again into TH1 and TL1, right? See, when the timer starts, these register contents will start decrementing. When it reaches to 0, then only overflow flag. So since again 20 milliseconds we need to give, loop 1 should go to, okay. This will get repeated for how many times? 5 times. So therefore, if you go for your waveform, How many times the waveform that has been generated? It is 20 milliseconds, 20 milliseconds, 20 milliseconds, again 20 milliseconds, 20 milliseconds. So like this, 1, 2, 3, 4, 5. So afterwards, it should start with, sorry, 1, 2, 3, 4, 5. Yeah, it should start with here on continuously with 50 milliseconds off and 50 milliseconds on. So therefore, what we have to do, we have to go back to the program. So yes, jump to start. Where the start should be for the very first instruction, which will make, or you can go for TMOD register or set B. So this one can be the start instruction. Okay. So and the final instruction supposed to be end. Is it clear, students?
Yes, ma'am.
Yeah. So now, if you go for,
Ma'am, that why will we load content into the timer register once again, ma'am?
where?
Near that loop one.
Yeah, I'll tell you. Once you load this TH1 and TL1 with, for example, you take this one itself. Okay. What is the value we are loading? 70C4H. Is it not? Once the timer started, timer starts. What it does, it is going to increment this 70C4 by 1. So it will become 70C5 for the first clock pulse, and for the next clock pulse it will become 70C6, and then for the next clock pulse 70C7, and so on. Until what is the maximum value this TH1 and TL1 can count? Upward? F. Okay. Once it becomes FFH, again you will be continuously supplying the clock frequency from the crystal, isn't it? So now, if this clock pulse occurs, again what happens? This timer register contents will get added by 1. When it is added, what will be the value? This will become 0000. What is now when overflow occurs? By this time, when the timer starts from 70C4H and goes up to FFF, how much you are providing a delay? It is of 20 milliseconds. After providing a 20 milliseconds, what is your TH and TL register is?
0000.
But what do we require as an initial value to have our 20 milliseconds again?
70C4.
Yeah, 70C4, it should be changed to 70C4. Is it not? Hence, why we have gone for this loop 1, 2, 70C4 initialization. Is it clear, Shishira?
Yes, ma'am.
Okay. Any other doubt? Okay, you say the next program, let me write one more program on timer, timer 0 or 1 in mode 2. Just a square wave, how we will be generating continuously. I think one program I have given you. Sorry. Timer 0 or 1 in mode 2, write a program to generate a square wave. This is a problem I am giving you. Square wave to be generated. which is having a frequency square wave of frequency 1 kilohertz on port pin P1.2. Port P1.2 square wave has to be generated of frequency 1 kilohertz with the crystal frequency has 22 megahertz and using timer 0 in mode 2. Fine students, is it clear now the question? Square wave we need to generate. Let us take a square wave waveform. This has to be generated having a frequency it's given. This on period and off period frequency it is 1 kilohertz. When time is calculated, 1 by reciprocal of that is time. Time will be equal to 1 millisecond. So now 1 millisecond, if it is divided between T on and off, so T on will be equal to, T off will be equal to 0.5 milliseconds. Okay, now this is the one part of the question analysis, and the other one is T-mod initialization. When you go for T-mod initialization, timer 0 in mode 2 we need to make use, whereas timer 1 is not in use. So therefore those bits we will be considering as don't care, but usually when we are assigning the value, you will be taking as 00. So now if you go for this particular timer 0 bits, gate pulse 0, then C slash T bar 0, mode 2 1 0. So this is equal to 0 to H. That is the T mod value to be initialized. TH1 and TL1 and TL0 and TH0 to be computed. So for that we have to go for this TD. So TD is equal to 0.5 milliseconds. So now 0.5 milliseconds. For that, the required time delay, if you are computing the final value minus initial value, this is mode 2, right? What is the final value that we need to find out? Let me explain that, and then we can go for the program write-up. So in mode 2, mode 2 is, as we know that it is an 8-bit auto reload mode. Yes. So hence what we have to do, this T, 12T, in the final value in an 8-bit auto reload mode, the initial value, if anything, if it is not defined to an well-defined required delay, initial value will be equal to 00. This 00H can be represented in the form of 8 bits as 0000000. In the binary, the final value, what is the final value? The counter can take, it is all the 8 bits to 11111111. So this is equivalent to FFH. So therefore here in the mode 2, the final value being FFH minus initial value is unknown to us. We need to compute and initial value. And we know that it is 12T, 12 into 1 by 22 megahertz. So if you are, this will be 0.5 milliseconds. So what is the value that you are going to get for this? The initial value when it is computed, it is equal to 48H. Thus, so now this will be for 0.5 milliseconds. So now that has to be repeated for 2 times. Please students, you calculate that initial value and cross verify from your side. Okay, what is the program now? Move tmod, comma, yeah, can you tell me what is the value that is supposed to be loaded onto tmod register? 02H, CPL, complement P1.2, square reef, move this one to move R0, comma, multiple delays. If you want repeatedly, you can provide. Otherwise, you need not to go for 5 times. If you are need to generate and you have to turn off, you can go for this. Otherwise, you can put it in, not necessary to put it in loop also. Looping technique need not to be adopted. Then move. Since it is mode 2, which register to be placed with initial value? TH0, higher order register. Then you need not to move any value with TL0 because automatically TH value will get loaded onto. If you look at here, timer or TL0, for this TL0, the input will be TH0. This TH0 will be loaded automatically in mode 2, and the TF0, based on that, it will set or it will be resetted based on the final count value. Once TF sets to 1, again it will give an instruction to the TH0 to reload this TL0. Hence, only initial value you load it on TH0. Then set B TR0, start this timer, JNB TF0, comma, back. So that back, let me write here, back to the same instruction, then clear TF0, then clear TR0, then yes, jump to repeat the process, where the repetition of the process need not be, because repetition means it is CPL. Repeat the process for this instruction. Please repeat, you can write it for CPL, and use the last command as end statement. Any doubt?
No, ma'am.
Okay, if all the types of programs related to timers I have done it. Okay, now let us go for these many programs. If you follow, if you study for your examination point of view, it is sufficient. Now let us go for counter programming. What is the difference between a counter and a timer? So for that, let us take tmod register first. Whenever counter operation you need to get from the same timer, so for that you need to first set the timer mode, the mode of configuration of the entire hardware circuitry into the counter. For that, you have to consider tmod register. In this tmod register, timer 0 bits as well as timer 1 bits, you need to slightly change it. How do we change that? So let us see now. If it is timer 0 or timer 1, mode 0, mode 1, it is as usual. Counter also can be used as 13-bit counter or 16-bit counter or 8-bit counter. But when you go for this particular timer or counter, 2 pins of 8051 we will be using. You can say this is an 8051. In the 8051, 2 pins, external pins, which supposed to be considered for a counter operation is P3.4 and P3.5. Okay, these 2 pins are representing T0 and T1. So it is an timer 0 or timer 1. What is this T0 or T1 represents external input to timer 0 or timer 1. Whenever the timer 0 or timer 1 to be used as counter configuration, external events happening should be connected to the P3.4 or P3.5. So these pins already you know, it is pin number 14 and pin number 15. Now what the other changes you have to make in this TMOD register, that is one important bit, it is C/T bar bit. For a timer, the C/T bar bit we were setting to 0, but here we need to make this bit to 1. When timer 0 as counter 0 you are using, when external pulses are coming through T0 bit, you have to set this bit to 1. If it is coming through the pin P3.5, then this bit has to be set to 1. So that is how, because C/T bar pin, that represents C/T bar pin. And this will be the LSB bit and this will be the MSB bit. So when you go for, as usual, the counters also you can make use as make use in different modes. So for that, let us see some what are the TMOD bits, how do we set. So if suppose timer 0 as counter we are using in mode 1 or mode 2, then how it will be. So let us see the configuration of this TMOD register. TMOD will be equal to, okay, so since timer 0 in mode 1 0, and what is the bit of this? This should be C/T bar pin should be 1, because timer 0 in mode 1 as counter we are using. So therefore 1, and then 0 1. Okay, mode 1, right? Mode 1, then this is 0 itself, and all other bits are 0 0 0 0. Okay, so this will be giving you as what value? 0. This is equal to 0.5H. Okay. Now we will take up few problems and we'll try to, that is the only change.